Hello everyone, my name's David Pike, the Connector Geek, and welcome to the latest in our series of Ask the Expert videos. We're here today to talk about something that certainly has made the headlines over the last few years. Renewable energy or alternative sources of energy are something that lots of people are looking at, whether it's solar, whether it's biofuel reactors, all sorts of different solutions to provide energy through renewable sources. And one of the things that we're going to have to cope with is dealing with the variations of supply that things like solar power will provide us. So we're here today to talk about ESS, Energy Storage Solutions. I'm joined today by our expert, Gijs Werner from Amphenol Communication Solutions. Hello, Gijs.
Hey, good afternoon. Great to be here.
Brilliant to have you with us. And I'm going to launch straight in with the simple and obvious question: what are energy storage solutions?
Yeah, that's an important question, obviously. I mean, in essence, electrical storage solutions are all systems, and especially subsystems, related to energy storage. These systems capture energy produced at one time for use at a later time. And we will talk about that in more depth, I hope, today.
And so the simple thing we've talked about now is what they actually are. The interesting thing behind that technology is what is driving the development and advances within the world of ESS, of energy storage solutions.
Yeah, first and foremost, I would say it's government regulations that's really driving advances in energy storage solutions. For example, in Europe, you have the 2030 new climate target with the aim to have at least 40% renewable energy sources by 2030. Or in China is still investing in coal. That is expected to peak by 2030, and they want to achieve carbon neutral before 2060. And last but not least, in the US, the Department of Energy is driving a decarbonized electricity grid by 2035. So that's very strong. But at the same time, we also see strong developments in technology, and especially related to battery management technology. We see cost decreasing, we see capacity increasing, so the amount of energy that can be stored in battery systems. And of course, what's driving energy storage systems, what we've seen over the past 2 years, I would say, is energy prices, which, due to conflicts in our region here, energy prices have gone up significantly. So that's also a driver for energy storage. And last but not least, related to government regulations, but it's the energy transition, right? We see more decentralization of energy production and consumption. And in this environment, in these trends drivers, energy storage solutions play an essential role, not only in the supply chain, but in the whole energy transition.
And so we've talked about, you mentioned battery management systems, and then you mentioned batteries. Well, I suppose the easiest thing to say is that these energy storage solutions are big battery solutions. But why is battery management so important when it comes to this kind of technology?
Well, we'll come to that, but an energy storage solution is not just like a battery, right? People might think it's just a battery system. It's, as I mentioned at the beginning, it's a whole set of subsystems. Battery management control is very important to monitor systems and to manage the efficient control of a battery management system. Yeah, so it optimizes the battery efficiency. So the battery management systems monitors and manages the battery pack in order to protect it from damage, to extend its life, and to keep the battery operating within its safety limits. So quite important, because it's a hazardous kind of an application.
Okay. And we've talked about the drivers, and we've talked a lot about government regulation around the world. But when it comes to specifically to individual users, or especially to things like commercial users, how is ESS vital for the commercial sector?
Well, commercial energy storage solutions. These are, I guess we're all familiar with this. These are the industrial scale storage systems you will typically find near wind or solar farms. And they're typically meant for frequency balancing, and I will explain. Because, the trend and the drivers towards renewables to solar and wind is great, but they have limitations, right? They only generate electricity with the right conditions, and that's not helpful when electricity demand is high and there's no wind or there's no sunshine, right? And in fact, approximately like 35% of the time, wind and solar are productive. And also when electricity demand is low, grid operators sometimes need to switch off their wind farms. Yeah? And so grid frequency balancing, as we call it, is critical to maintain national power supplies. And energy storage systems play a really important role in enabling power grids to function with more flexibility and reliability. Yeah. Like I mentioned, a commercial energy storage systems are these container-based systems you see near wind farms and solar farms. It's not just a battery, right? It's basically built out of three main systems. It's the battery management system we talked about, right? The monitoring system that manages the efficient control and monitoring of a battery system. So it optimizes battery efficiency. But it's also the energy management systems. Yeah, that includes all kinds of functionality, electronics to maintain the optimal and safe operation of energy storage systems, including utility interfaces, because it's part of a grid. And that's also the third system is the power control system. That's the system that controls the output of the energy storage system. Yeah, and by doing so, limiting the cost of potential additional equipment needed to the electricity grid. So it's like I said, a set of important subsystems.
That raises an interesting point that is not in our notes to talk about today, but I just want to reiterate the importance of the output from these systems, because obviously we're using wind farms and solar farms to insert energy into the grid, and we rely on very regularized power in terms of frequency, in terms of voltage, to make sure that all our equipment run. And I'm guessing that's what you're saying about when it comes to power management systems. We have to make sure that the energy that these systems insert into the grid are compatible with everything else.
Absolutely. And in essence, it's really important, of course, to maintain a grid efficiency and operationability, right? The last thing we want to do is grid shutdowns, etc. So the grid operators are really keen on maintaining the reliability of the systems.
So we've talked about energy storage solutions from the commercial point of view, the role they play in creating this supply into the grid. What are the interests in ESS solutions for residential users?
Well, I would almost say increasingly so, because the same principle applies for residential users, right? Like homeowners. Electricity is not always being used at the same time it's being generated by, the increasing amount of solar panels we see, especially in Europe and Japan, on our rooftops, on our parking garages, on our buildings. And obviously you can sell back solar power to the grid, the net metering system, but more and more countries and governments and utility providers are phasing out this possibility. So you need to store. And this can be in several ways too, right? You can, for example, charge your electrical vehicle, and use this as a battery system. So this is called bidirectional charging. So EV charging that goes two ways, or by using again a battery pack. And also here, a battery pack in not one system. It's a whole set of subsystems. So the battery management systems, and also a subsystem because it communicates with all kinds of other systems in your house or in your building. It's also for your building. It's also called a home electricity system. And
so energy storage systems are becoming part of the smart home You talk about them communicating with the rest of the building, and on Design Spark, we've talked about the smart factory and the smart home quite a lot recently. So there's a role for these energy storage systems to play in that increasingly intelligent smart home.
Absolutely, yeah, and very importantly, that means that all the subsystems need to communicate to each other very well. And so this is not only your battery storage system, it's also your inverter, it's also your switch panel, it's your appliances, it's your security system. Again, you need a battery management system to monitor that. And maybe like a sidestep, battery management systems are also being used in electrical vehicles, right? And there we see the battery becoming so important, and the battery management system becoming the brain of the car, right? And I see similar developments happening in residential and commercial energy storage systems as well. The battery management system becoming a very essential part of the residential and commercial energy storage solutions.
And that actually leads us on to one of the things that's, bear in mind I am Connector Geek, is one of the things that I found the most interesting. We're talking about all of these systems communicating with each other, and all of these systems sharing power. So that everything needs to be connected. Mm-hmm. And so the next question really is, how is the development of these energy storage solutions changing connector design?
Yeah, so energy storage solutions, that's all about, like we discussed, like we talked about, it's about communication, control, and distribution of power. Yeah. And maybe it's not so much changing the design. I mean, the same principles apply for connected designs, but for energy storage solutions, certain aspects are more important to ensure reliability of the whole system, right? And I believe also energy storage system are a very good example where technologies from different types of markets, whether it's like automotive or industrial, come together, right? So you see, my experience is you see system designers, component engineers using best of both worlds, right? Because these systems are being installed, especially, well, let's start with commercial energy storage systems in remote locations, right? They need to run and operate for many, many years. So performance reliability is key, right? A false meter reading is a costly error because you need to send somebody over to check if everything is okay. And that comes at a cost, obviously. Yeah. And even though these systems, commercial energy storage systems, these container types of applications, yeah, they're protected by a metal case. They're typically air conditioned. Design engineers don't want to take the risk. Yeah. So even in these container types of applications, you still see the need for sealed solutions to cope with potential moisture in the application. What you see is they typically go for dual beam contact systems to have a good electrical reliability over time. I mean, even in these remote locations, you have to deal with like micro vibrations, right? If it comes to power, you need to have the right creepage and clearance distances for your power interconnect. So there's not really a need to go very small. We even see like a trend to go larger, to increase those creepage and clearance distances. And you see quite a lot of component engineers looking at the automotive interconnect market specifically, because a lot of the battery management developments are coming from the automotive side. And some of the battery management companies are, either doing or are doing automotive battery management systems as well as residential commercial battery management systems. So they look at their robustness, high performance of automotive interconnect, especially with regards to vibration resistance, because typically these errors like false meter readings, etc., do not occur like the first 3 or 5 years, but thereafter. Yeah, after like 5-7 years, it comes down to the nitty gritty detail of interconnect, having the right amount of plating and the right porosity, the right shape of the pin tip. Even it goes to these kind of details. That's where design and architects and component engineers are looking for.
No, that's really interesting, and I'll come on to that point in a minute. But Well, you've mentioned the architecture literally just now. You've mentioned the designers and the architects. It's interesting in certain areas you see regional differences, but when it comes to designing solutions for ESS and for this kind of power distribution, are there differences between regions? Are we seeing different trends in the Asia Pacific region to the ones that we might find in Europe?
Yeah, if we look at, let's start with the battery pack itself, right? I mean, the battery pack is typically constructed based out of a couple of cells being connected. I would say the predominant system architecture to connect those cells in Asia is by means of a flexible printed circuit, yeah, which is lightweight, easy to assemble, cost effective. Yeah, where we, until like, I would say recently, like a couple of years ago, we saw the US and Europe more focusing on discrete wire solutions. I mean, typically coming from the automotive area, right, where discrete wire is a very common way, which is increasing the wire complexity, especially if you have more functionality like control. So we see architectures are migrating. I mean, all those battery management, battery pack, I have to say, builders are looking at each other. We see it migrating, right? We see now also more flexible circuit architecture being used in Europe and US. And I mean, the latest is, I would say, we see kind of a combination even, yeah, a combination between a flexible printed circuits tree in combination with discrete wire. Yeah? So that requires flex to wire or wire to flex connectors. So yes, there are differences at the end, I would say. And our experience is it highly depends on the system architect, what his or her preferences are.
And we've talked about a lot of the things that are coming in the future. We've talked about the government targets for net zero carbon infrastructures. We've talked about the reduction in the emission of fossil fuels. What is the future of ESS? Now, I'm guessing that the future of ESS is bright. But what trends are we expecting to see for energy storage solutions over the next 5-10 years?
Yeah, I mean, some obvious ones, I would say, right? I mean, I believe we will see costs coming down, decreasing cost. Yeah, so the cost of manufacturing, the cost of installation, that's really expected to come down because we have better building practices. We know better how to assemble them, those kind of things. Also, advancing technology. And economies of scale helped to that. We will see an increase in energy density. We already see that in the automotive sphere, right? We already see the battery capacity increasing. So the amount of energy that we can store in a given volume of mass will increase. Yeah, that's because of technology advances. I believe we'll continue to see an increasing use of software and data analytics. There's a lot of data being collected. We see more and more systems like in your home being connected. Software plays an important role there to control and manage energy storage. And I believe in the automotive area, Tesla is a perfect example of that, right? I mean, they're leading also in software development. So yes, I mean, these are some important trends, I would say. And yes, I believe it will also continue to grow with the like we started off by outlining the government initiatives. So we will see more energy storage systems. I believe it will also expand in new markets. We have seen it, the battery energy storage systems being used in automotive. We see it in residential areas, in commercial. We see it now in warehouse robotics. We see it in robots. It will expand in other markets as well. So that's I believe for the future. And I believe also there will be a stronger focus on sustainability because materials being used for batteries, they're being mined, etc. So there are some environmental concerns, as we all know, with regards to that. So we will be looking for new technologies, also new technologies to store energy. But overall, I believe, the future is bright, right? New advances of technology, and it's being more widely adopted. So that will continue to grow, and that will also continue to drive innovations, I'm sure.
Fantastic. Now, we've talked a little bit about some of the connector technologies. You've mentioned wire to flex, flex to wire. If we look specifically at the Amphenol offering, Amphenol obviously is a very big player in this market. Are there some important ways in which Amphenol is supporting designers in this area?
Yeah, absolutely. Well, first and foremost, because, energy storage solutions is a key application for us, a key area where we want to focus. And our experience is where we focus, we win. Yeah? And we win because we have a lot of value to offer to system architectures and component engineers to make their systems more efficient, more compact, more reliable, more durable, more cost effective. And that's not only on the battery management communication side with high performance signal connectors, but we're also very strong and known in power connectivity. So we continue to develop new connector systems for energy storage solutions. And we're going to expand our current ranges. Yes, you mentioned some of the latest additions we've done for a family called FlexLock, flex to wire connectors, or for WireLock, wire to flex. But also a good example is our power offering within Amphenol Communication Solutions, for example, PowerBlade Plus or CoolBlade. Those are also important solutions, and also important to mention, for example, single pair Ethernet, a development strongly driven by the industrial environment we see also being applied for energy storage solutions. All the developments we discussed, right, drives innovation also from our side, I would say. And we will be continue to be at the forefront, developing new technologies to make energy storage systems architects and component engineers successful.
That's brilliant. Now, this is a topic I'm particularly interested in, and I think hopefully you'll all have gathered that energy storage solutions are here to stay, and they play an enormously important role in our quest for more sustainable energy use. And the applications for it, not just commercial, but domestic and beyond, give us a lot of scope for new developments in terms of technology. Amphenol is one of the largest connector companies in the world, and they have lots of offering, as Heise has just told us, in lots of areas. I'm very interested to hear that the role of, say, automotive connectors in this particular environment is something that is encouraged. I've talked about automotive connectors in the past, the fact that they are so suitable for non-automotive applications. They're often sealed, they're often lightweight, they're often very reliable, they're often available very easily at low costs. And so they bring all sorts of advantages to engineers. So hopefully you've got an understanding now of what energy storage solutions are, a little bit of understanding about how they will develop, and some of the connector technologies that people are interested in using to deploy them. If you need more information, DesignSpark has a ton of information about sustainable energy. We've talked about energy storage solutions before, and obviously we talk about Amphenol connectors within that. And so there's a lot of information that you can gain from DesignSpark. RS Web has a lot of offers for the Amphenol connector range, including many of the ones that Heise has just mentioned. So if you need more information about specific products, please visit the RS Web to go and get more info about that. I think the last thing for me to do is to thank Heise for your time. I've been very interested in this conversation and this application. So thank you so much for joining us and giving us all this information about the energy storage solutions of the future.
Yeah, thank you. It was a pleasure talking to you about this very interesting application.
Lovely. Thank you very much. And thank you all for watching. Join us next time for the next Ask the Expert video.